Hello and welcome to Mr. Ridley's RMT revision, and this is number 5, and this is metal processes and finishes. So the first process we're going to look at is sand casting. This makes products such as this, which are made by pouring metals such as molten aluminium into a sand mould. So let's just have a look at the process of sand casting, and there are 6 steps we're going to look at. First of all, a wooden pattern is placed in the sand to create a mould. A lid is put on the top to make the top half of the mould, and a system to allow a gate to allow the molten metal to be poured into the mould. The pattern is removed and the mould put back together, leaving a cavity, a hollow space. Then the mould is poured in. Aluminium or brass can be poured in and filling the empty cavity with molten metal. The metal is allowed to cool, the sand is broken away, and the casting can be removed. These are finished castings. Quite often they need machining before use, so quite often they're quite a rough surface finish. You need a smooth surface finish, they need further work. Hot forging. Iron and steel can be shaped by heating the metal to high temperatures, then hammering to shape. This can be done by hand here. There's a blacksmith's, or in a factory it can be done by machine. Drop forging is another method of hot forging, and this is done by placing very hot steel between 2 hard moulds or dies. The top tool is then hammered down repeatedly until a shape is formed. Forging steel creates a grain structure. You see a grain structure here, which creates a much stronger product than casting or machining, and you can see a spanner here actually got on it, drop forged, to show that it's a strong, well-made product. Heat treating metals. Now there are various heat treatments of metals. Steels can be heat treated to increase their hardness, especially high carbon steels. Steel tools such as dies, knives and forming tools, like we can see here, need a hardened structure to help resist wear and also deformation, to bending about. So the first process we're looking at is hardening. Steel is hardened by heating to a high temperature, so orange or red hot, and then placing into the hot metal into a bath of water. The rapid cooling changes the structure of steel, hardening it. So you can see that process there. That is hardening. Tempering. Once metal has been hardened, steel has been hardened by quench hardening, it is very brittle, and small impacts may cause fractures or cracking. Tempering is a heat treatment that reduces the brittleness of the steel without significantly lowering its hardness and strength. All hardened steels must be tempered before use, and here we can see some knife blades that have been tempered to leave a hardened edge, but to prevent them from cracking or snapping. Now we're looking at annealing. Annealing is carried out on metals before working with them. This is to soften the metal and make it more malleable and easy to work. Annealing softens the metal, which means it can be cut and shaped more easily. So this is annealing. So here we can see that a piece of material being heated up and allowed to cool gently. Mild steel is heated on a red heat and allowed to cool slowly. Copper is annealed in a different way. There's a piece of copper being worked. So annealing softens the material and allows it to be worked. Now we're looking at some machining processes, and we're looking at milling. Milling cut shapes by holding a piece of metal. Here's a block of metal here in a vise, and a cutting tool rotates and moves past it or moves across it to remove metal and leave a flat surface. CNC milling. CNC milling, or computer numerically controlled milling, is done by milling machines controlled by computers. These machines can produce very complex shapes in metals very accurately, normally working from CAD drawings. So machines such as this will take a CAD drawing, and from the CAD drawing can cut out a very intricate metal shape. The metal lathe. Now there's lots of processes, or a few processes on the lathe that you need to know. You may also need to know these basic parts of the lathe, such as the headstock, chuck, tool post, tailstock, bed. There would be common ones you may need to know. The metal processes, or the lathe processes we need to know, are first of all parallel turning. Parallel turning is where the tool, the work rotates, the tool moves across to reduce the diameter of the work. Facing off. Facing off is where the tool moves at 90 degrees to the spinning work to make a smooth and right angle cut. Center drilling. This process uses a stationary drill in a chuck here, and you can see the work spins and the drill drills into the center. Holes that are center drilled on a lathe are always exactly in the center of the work. So that is center drilling. Knurling. Knurling is this process that gives a grid pattern onto the work. The work is turned in the chuck using this tool here, a knurling tool, which is hardened steel, and this cuts, as the work turns, it cuts this grid. This kind of finish is used on things like, there's a BMX foot pegs there, and they've got that knurled finish on them. Parting off. This process is used for removing material or cutting off a completed workpiece. So it's a very thin tool there, and it's just pushed in, often with coolant, and that would just cut off a disc or a finished part. That's parting off. Now we're looking at some metal forming processes here. This one is cold pressed steel. So this is where thinner sheet steel is pressed between dies or formers to produce complex shapes. So here you can see the principle on a simple shape, but this can be done here with a more complex shape where it's pressed between formers. Extrusion. This is a process used to create metal objects of a fixed cross-sectional profile. So the metal is actually pushed through a piece of hard material with a hole in it called a die, and an extruded shape is pushed out. So here's some aluminium sections that have been extruded. This is the same process that is used for a lot of different things, and that's how spaghetti's made. So there's the same process used on food, and also concrete it can be used on. Okay, so we're going to look at some finishing processes now for metals. So obviously the first process is painting. Now ferrous metals like steel need to be protected. They need a protective coating, or when combined with oxygen in the atmosphere and water, they will rust. So paint relies on just making a water and airproof barrier to protect the steel underneath, and here we can see the paint coating just protecting it. Metal paint usually consists of a primer and top coat, and can be applied by brush or spray painting. Plastic dip coating. This is like painting, but is a more durable and a thicker surface. Plastic dip coating is made by dipping metal into plastic. It acts as a protective coating on the finished product, and we can see some plastic dip coated products here. Increases the useful life of a product, and it can be used for decorative purposes, and it can also be used on things like this pin here to give it protects from sharp edges and heat. So here's the stages in dip coating. Here we've got some more dip coating products. So you've got a pair of pliers here. The metal item is heated in an oven. The hot metal is lowered into a fluidized plastic powder. This is a bath of plastic powder which is has air blown through it, so it's acting as a fluid. The powder then sticks to the metal and fuses together. The the item is withdrawn, and the plastic cools to leave a smooth, and fuses together to leave a smooth, durable coating. So that is plastic dip coating or plastic powder coating. Another finish here, electroplating. Electroplating is done by giving a shiny protective layer that can be given quite cheaply to metal, and works to add a protective layer that will stop the metal from corroding. So often here's some brass taps, and they've been covered in chromium plating. They've been chromium plated which obviously is a much more durable, harder metal and very resistant to corrosion. So it gives a hard surface. It also makes the product more attractive and increase sales of the product. The product can obviously be sold for a higher price, maybe an equivalent to price something that was made of a more expensive material like stainless steel. So that's chromium plating or electroplating. Hot dip galvanizing. In this process, the steel object is placed into a bath of molten zinc. So here we can see some railings, and these railings are being dipped into a bath of molten metal, which coats them, again like a dip coating, but it coats them in another metal. This metal is very durable because the steel is also protected by an electrolytic action, so a very durable surface finish. That's why it's used on things like railings and that, to stop them rusting. Now it's time for questions. Name 3 finishes that can be applied to protect mild steel from corrosion. Painting, plastic dip coating, and galvanizing. Which metal processes can produce very complex shapes from metals using CAD drawings? CNC milling, that is computer numerically controlled milling. This process is hardening. This process changes the structure of steel, hardening it and strengthening it. Metal processes. This process is forging. This process shapes and strengthens steel. You can see here the grain that's built in by forging. Which metal process can be used to make metal sections and also spaghetti? Extrusion. This is where the material is pushed through a die to form an extruded shape. Which metal process was used to make these aluminium products? It was sand casting. Can you remember these names of these lathe processes? Knurling, facing off, drilling, parallel turning, and parting off. Well, this has been metal processes. Thank you very much for watching, and good luck in your exam.